Yeah, so I wanted to thank Nick Jarbo and Karen Stocks for really leading the charge and keeping the Council of Data Facilities discussions going, because I think there are a core group of infrastructure providers and data facilities there that have really benefited from and keep coming back to this theme that we have things that we could do together, that we could share together, that would make all of our lives easier and make it easier to create resilient repository infrastructure. So we came up with the idea for this session, and I think it's going to be a useful discussion. The plan is for us to have 6 sort of lightning talks and a 45-minute breakout session for discussions. So we're sort of dividing the session in half. During that whole first part of the thing, I've put up a Slido poll up here. So if you use this QR code, you can go. Please try to answer the questions during the thing, and we'll revisit the answers to those at the beginning of the discussion period. So sometime over the next little time, try to fill out that poll. The links for that are also in the document that ESIP has provided for the session notes. So please remember to sign into the session notes and try to list your name and organization that you've been here. We'll try to get a sense of who's been participating in this conversation. There are also links to the slides and to the Slido poll in the resources section of that document. So what we're hoping to get out of this session is to basically have a bit of an overview of the kinds of repository infrastructure needs and repository infrastructure services that groups could provide, and have a discussion that tries to crystallize the ways in which we could build kind of from the bottom up into networks of sharing infrastructure. So that's the goal for the session. I'm going to start off by kind of framing the problem a little bit and thinking about why we would want to share infrastructure in the first place. I think everybody here is probably familiar with Data One, which is this network of repositories that we've been working on for a number of years. There's currently 68 repositories in the network. The idea behind Data One, that working on an interoperable data federation, makes us stronger together, that we basically can do more with our money. We spend less time building infrastructure, we can improve services, and we improve sustainability by working on things as part of a network. And I think today in 2026 is just as true as it was in the early 2000s when we came up with this network idea, that interoperability and shared services are a critical part to making things work well. So what kinds of things might we want to share? So, I mean, obviously, repositories in the business of storing data. So shared storage, shared compute makes sense. Those are obvious sorts of things. But I think shared software is also one of those things that we might be able to work on better. One of the visions for Data One was that by standardizing a loosely coupled, lightweight API across repositories, repositories could plug and play different software components into that stack and utilize, say, shared metadata editors or shared visualization systems or other things. And I'd say, although Data One's been a success in many ways, that hasn't really materialized. People still build their own systems for pretty much everything on the software side. And I think a lot of that is the built infrastructure problem. Everybody has an infrastructure. They've been working on it for a while. It's really hard to switch and change gears. Even if you think it's a good idea, the sort of cost of doing that is quite large. Another thing that we could really do a better job at sharing is people. So we all have, a variety of different levels of expertise. We have data curators, we have research software engineers working on our teams. I know if you're like us, we have a hard time sustaining those positions over time, and working as a network to try to do that better would really help us to potentially keep continuity and provide cross-repository expertise. So I want to give a couple of examples of shared kinds of services that we think have worked out well, and other areas that we might want to see stuff that can arise. I see a number of different categories of shared services. Like one of them would be like shared metadata services or shared, shared authentication services or other types of things that most repositories use. We could be sharing more open source software. I mean, how many people in this room have written and built a metadata editor? I bet a lot of people, or at least your repositories have. And so we all are collecting the name, title, and contents of data sets, curating them and depositing them into a repository system, right? So there's probably a lot of redundant effort there. There's also data storage as a service. We'll hear from TAC a little bit later today about some of those types of opportunities, and then hosting and infrastructure as a service that we might be able to use. So here's a concrete example. Data One for a while has been providing a metadata assessment service. This is a kind of a comprehensive look at a metadata record from either ISO or EML format that Ted Haberman and I developed a long time ago. We run it on all the million data sets in Data One, and it produces a pretty nice report. But it didn't work for schema.org. So one of the nice things about Data One Network is that Martin Soul approached us a few years ago and said, we want this thing to work for schema.org. And so we worked with Martin and Lindsay from their team, extended it to work for schema.org. Now we have those sort of this third dialect working. And as a result, 16 other repositories that use schema.org as their primary language within Data One get metadata assessment reports for free. They didn't have to do anything, and they all get these sort of comprehensive assessments of their metadata. So working together, it saved a lot of time through that system. Here's another example. I've alluded to this a couple times. So we all work with metadata systems. On the left-hand side of the slide, there are 3 different repositories: the Stony Coral Reef Database, the Arctic Data Center, and the French National Biodiversity Data Repository. They all use the same Metacat UI metadata editing platform. It's a JavaScript platform for metadata there. On the right-hand side, you have the Canadian Watershed Information Network, basically Open Data Canada and Open Data US, and hundreds of other groups that use the CCAN platform. So there are others, platforms like this, the Dataverse platform, the GeoNetwork platform, others, where people can work as communities to build out an open source software platform that many people can utilize. So this kind of like sharing is really beneficial. Within Data One, there are over 20 repositories that are currently using the Metacat UI software platform. And so we can basically amortize the cost of developing the platform across a number of different repositories that are operating in really widely different domains. Now, of course, that's a small fraction of the 68 member repositories in the network, and many of them use these other platforms. So there's a cluster of Dataverse nodes, there's a cluster of CCAN nodes and others, but there are a lot of repositories that have built their own bespoke metadata system, and they are the only repository in the world that uses that platform. And as a result, they are the only group that maintains that platform, which is very expensive to do if you're working by yourself like that. So I think this is a real opportunity for us to think strategically about what are the software platforms that we as a community could do a better job at sharing and building open source ecosystems around. So I'll come back to this slide. That storage, compute, software, and people, there are many other different things that we could be sharing, across the community. I'm not going to go into all of them. Those are just some examples. But I think that there are some real benefits to potentially doing that. The plan here today is to basically go through these additional 5 lightning talks. Each one of these people represents a data repository or a facility that both probably has infrastructure needs and has infrastructure that they could provide. And we're going to have people kind of give you a sense of what things look like from the repository perspective. And then we're going to come back and have a discussion about how we might make some of this more of a reality. So we're going to start with Nick Jarbo from Magic. He's going to talk about that, and then we'll move through the rest of them as we go here. So I'm going to switch over to Nick's slides here.
Thanks, Matt.
As we're doing the transition, I can just pause for a second, see if there's any questions in the room. I'll remind you that in addition to being here in the room, you can also use the Q&A on the Slido poll, and we'll try to come back to those and look at those as the session comes to an end here. So, Nick, the slides are up, and when you're ready, let me know, and I'll work my way through them.
All right, great. Thanks everybody for coming. I'm sorry I couldn't make it down there to Texas this time of year, but I'm glad I can present here virtually. Next slide, please. I'm Nick Jarbo, and I represent the Magic Data Repository, which is a paleomagnetic and geomagnetic paleo data repository. And we have been supporting this repository for about the last 20 years. In the most recent software upgrade, we decided to try to make our system more flexible to allow other sample-based repositories to use our software system. And so we created what we call a Fiesta software stack. Um, Next slide, please. So our group has been over a variety of different um, universities. We have people at the University of Minnesota, UCSD, at SIO, and at Oregon State University that have been PIs and other supporters and workers on this project. Next slide, please. Um, Magic was the base repository that supported most of this work, but we have expanded out to a partition coefficient database, an argon geochronology data repository, a core data repository for drilling samples, and OSU also uses this software for their marine geology core repository system. Next slide, please. So we've developed this system where we have a variety of features that you would need for a data repository, and we're focused on samples. So we don't have a large data sets, but we have a lot of needs that we had. So we basically have a web interface. Um, we have data sets and their versions so they can be updated, and each version gets its own data DOI. We have a search interface. So you can do text searches or searches over basically any of the fields in the database. We have upload tools online, and we also have Python tools. We have private workspaces where your data can be available to yourself and colleagues, and editors and reviewers before it's published for everybody else to see. We have we do archiving, of course, and data DOI minting upon publication of the data set. We have a full-fledged API where you can upload, download, change the data set via an API. And all of our data sets, we've been working with the sciencesonschema.org cluster here at ESIP, um, and we have the schema, sciencesonschema.org metadata headers on all the data sets, and that's built in. So basically, with this system, all you need is a data model, and then you can get all of these systems with little extra customization. Next slide, please. So currently, these are the technologies that we're using, but Meteor and Mongo are sort of systems that we're thinking about moving away from, and so we're at a stage here where we might be willing to bring these data repositories onto a new platform, or collaborating with people. All of our code is open source, so we have GitHub site where all of these different feature sets are available to be worked on. But currently, it's just our core group, and we haven't reached out, or well, we've tried to reach out, but we haven't developed new collaborators and people outside of our group to use this software separately. Um, Next slide, please. Um, so what we have dedicated hardware at OSU. We've got 3 servers that are mirrored with hardware and data storage. Um, We have this configurable custom open source data repository software stack that's used over different repositories, um, but within this small core group. We have NSF funding, which is not always continuous, but we can make improvements with our funding streams. And since we're sample based without many images, we have small data storage, so that's not something that we really looking to necessarily need to share. Um, what we would like is to find other groups that would be interested in either using the software, or we could migrate to their system so that new features and just the amount of people work that it takes to keep a data repository running could be lessened, and looking for ideas for sourcing that could be outside of NSF as more uh, sustainable or robust funding stream. So that's where we're at, and hoping to meet people that have similar needs or systems that we might be able to collaborate with. Thank you.
Yeah, thank you, Nick.
Martin Doyle. I'm working for Quasi, and I'm currently the lead of software engineering here. And most people might not be familiar with Quasi. We are a consortium of the Universities for Advancement of Hydrologic Science, long name, so short as Quasi. And we are a nonprofit community organization, mostly focusing on supporting the water research community through infrastructure, education, and community programs. I'm focusing on the infrastructure, which is biggest one we have is HydroShare, which is a domain repository that we operate essentially for sharing, analyzing, and permanently publish hydrologic data, models, and code. So very similar to many other people here. It's our domain repository. And what I'm focusing this here in this talk is mostly on the storage challenges that we have out of the many different things that we could talk about. So a quick overview of what we've been doing. So we started as an NSF-funded research project outside of Quasi. We were just a collaborator. But then in 2018, we took it on as a production system. And since then, we're operating it as a repository for our domain. We moved it from a research facility at Renzi to the commercial cloud in 2023 as the project ended. We had no servers to install. We had no funding for setting up our own cloud. So for us, it was obviously, we tried the commercial cloud. So we had no university or facility that would take the data. So we are entirely dependent on NSF and NOAA grant funding to pay for our storage and the services. So, and our data holdings is around 10 terabytes, so not particularly big, and it's mostly long tail data that we are really supporting the community. And what this means for us, so when cloud costs rise, we have to somehow absorb them. So when grants are cut, our data is at risk. So we have really no fallback outside of the commercial providers. So what we would really could some help with, and really where we could really work together is really we have a lot of challenges with our data store that we have. So we have no offsite data backup. So the entire archive lives in the cloud. We have limited outside redundancy beyond what we currently have there. We have to limit the quota for what people can use, because we can't. We have to limit how much storage you can pay for. And currently, we don't have a long-term archival option. It's archived at AWS, at GCP, but you still have to pay for it. It's not really offsite somewhere else. So what we would like to really collaborate maybe with larger facilities or across different organizations in the community to have some access to on-prem or shared facility storage, as we can't build it ourselves. This would be a supplement what we have in our commercial capacity. So this could really help with reducing the costs and the exposure we have within our provider. And we could also then maybe serve the community better by provide larger allocations for the researchers, as we all know, the data needs are continuously growing. And what we also would like to think about, maybe have a more data archival agreements, so to keep data with other organizations, so we can really provide an archive that stays accessible even if we lose funding. So what do we bring? As we don't really have any infrastructure that we can bring on the hardware, but we do bring human infrastructure. We do have experience migrating a full scientific repository to the cloud, operating it. We can help other groups to see what worked, what didn't work, and really teach lessons, really understand what so we don't repeat the same mistakes again that we have made. We have a storage pattern for SD compatible implementation. So that's a usable pattern that we have. And we can really have an understanding how the data is used and the costs of running a system. So where I think we can really work together, we can connect smaller repositories to existing NSF storage facilities to really help with provide better offsite and low-cost archival. We can document the integration that we have, so every repository is not solving the same problem. We can establish data custody agreements, maybe across many different organizations, to really help with archival and repository loss in case somebody loses funding, and really create a peer network to share experiences and operational knowledge across repositories facing similar constraints. And what Matt said earlier, really identify opportunities to share actively infrastructure within the repositories, so to not reinvent the wheel as many times as we already have. And maybe in the long term, really work towards a more distributed and shared earth science data facility network as a more sustainable long-term science infrastructure than what we currently have. So that's all I have. So any questions to that, or do we have to move on?
No, I think we can take a question if you want. And let me just say, I think I messed up on the poll a little bit. So the poll is not as auto-advancing as I'd hoped. So I must be a Slido newbie. So I'm going to sort of slowly step through the poll questions, and please go ahead and answer them. I'll throw that up on the screen for a minute while Martin, go ahead. And if anybody has a question for Martin or the other speakers, please go ahead. So this first question was, are you directly involved in operating a data facility? The link it's in the notes document, but it's also
what was the hashtag?
Right there. Infra is the hashtag. Yep. So I'll leave this up for another couple seconds, and then I'll switch to the next one. I'll just slowly page through them as we go. And any questions for Martin?
I was just curious. I mean, in discussions we've had about this.
Microphone, please.
Oh,
Sorry, just so the folks have like it.
okay. In the discussions we've had in the community about resilience and sustainability and collaboration, very often domain or discipline specific networks have come up, especially on international level. Is there anything in hydrology that would offer those opportunities to work across national boundaries in finding backups for the data?
That's a good question. I actually don't know. I think we have focused a lot more on the US with what we have been doing. So that's why. So we have our data holdings are not just the US. So we have many people even from Germany coming to, because though it's so there seems to be a need for that. If people come from Germany, come to us, and from Europe, but I don't know about a different repository. Something we should really I should inquire a bit more about that. It's a good question.
I think, I mean, the seismology network has been brought up in these discussions where kind of formal agreements have been made between large research infrastructures. And I think this is a really good way to explore at least the opportunities, because the data then gets to be the stewardship with the expertise that is needed for that particular data type.
Yeah, that's a good point. I think that's something we should, we have been mostly focused on the US, also with collaborators, but that's probably something we should expand our reach to go also beyond beyond the US, as we have data holdings that are bigger than just not just for the US, but also other countries. So, yeah, good point.
Okay. So I'll move on from the Slido question in just a minute. We'll transition over to Jeanette Clark, who's going to talk about some of the services at the Arctic Data Center in Data One. So Jeanette, this is ready for you when you're ready.
All right, thanks, Matt. So yeah, I'm Jeanette Clark. I'm going to talk about Data One and Arctic Data Center shared infrastructure. Go ahead. So our infrastructure, design and what we've implemented is really built upon this, a good problem to have, that the Arctic Data Center is growing at a rate of about 17 terabytes per year. So this shows the total data volume over time. And this 17 terabytes a year actually undershoots our storage needs by quite a large margin, because we replicate our data in triplicate. So by this, linear trend, we would need about 60 terabytes per year. Plus, we store a lot of non-archival products like images derived from satellite data and things like that. So the Arctic Data Center is growing quite a bit, and it's growing, as you can see, we have these big steps. So we tend to get very, very large data sets, like a handful of large data sets at once, that will dramatically increase our storage needs. Go ahead, Matt. So when we think about our cyber infrastructure needs as a whole, scalable storage, like I just mentioned, is definitely one of them, where we need to be able to easily add or swap out storage. In addition to scalable storage, we need our services to be reliable and responsive. We need all of our data to be organized and indexed, and we need users to be able to retrieve the data in a reasonable amount of time. And on top of all this, we want to maintain our core, repository responsibilities of having strong versioning and robust metadata. And so all of these cyber infrastructure needs point us to wanting to implement a microservices architecture, which happens to be the blueprint of what cloud service providers call the cloud. Go ahead, Matt. And so we did, as part of our grant renewals, we frequently do on-prem versus vendor comparisons for how we might implement this cloud native infrastructure. And so at the top here, we have storage. So for storage, to get the amount of storage that we need for on-prem, the costs are about $1 a terabyte per month, compared to between $8 and $12 for some of the for Wasabi, Amazon, and Backblaze. So these are the similar costs per terabyte per month. So it's much, much less expensive to implement this on premises. And similarly with compute power in the bottom row, to get 768 cores with 1.2 terabytes of RAM, we'd expect to spend about $200,000 amortized over 5 years. This on-prem for storage is also amortized over 5 years. So this is about what it costs to get that much compute power. And if the equivalent cost on Google Cloud Compute is about $40,000 a month. And so this basically pays for itself in 5 months hosting our compute on premises. So just from a cost perspective, it makes a lot of sense to do this on premise. Go ahead, Matt. And so the result of this is us building our private cloud where the infrastructure looks like we have a set of dedicated compute nodes. These are all orchestrated through Kubernetes, where we have application containers like our front end, Metacat UI, and back end Postgres and Metacat, all running on these compute nodes. And these compute nodes then access our storage cluster via Ceph. Ceph allows us to easily add storage nodes to swap out nodes for machines that have reached the end of life. It allows for easy replication between nodes. So this is the sort of infrastructure that we've set up. Go ahead, Matt. And this infrastructure is shared, this private cloud, by 6 different Data One member nodes. And so we have the Arctic Data Center, obviously, and the KNB, and a couple other examples here. And the way that we've set this up is where all of these member nodes are running their own front-end and back-end services. So they all maintain, their individuality on the system, but they can all share these common services like our metric service, our authentication service via Keycloak, our data quality assessment. And so that makes things work really seamlessly when we have them all sort of on the same system. And some of these services, particularly the data quality assessment, really, really benefit from having everything on the same hardware. Go ahead, Matt. And so this is part of what Data One can offer, is this infrastructure as a service. And so we've been doing this hosted repository program for a number of years now, where we have 11 hosted repositories. Some of these are hosted on that private cloud, some of which we host on virtual machines. And what Data One provides is the maintenance and operations for these repositories for a relatively low cost. And we have our sort of flagship grants that support, for example, the Arctic Data Center or ESS Dive, or what help us fund developing new features for the software that backs up these hosted repositories. And so we've tried to build this ecosystem where we can continue to support repositories and have that maintenance and operations costs covered, while also writing grants to develop new features. And so this is part of what Data One can provide, is this infrastructure, but infrastructure is also part of what we need. Data replication across different geographic locations is super important to make sure that we have reliable backups. And so being able to replicate some of our data outside of California without incurring, the astronomical costs of replicating it to like Amazon AWS or something like that would be a huge benefit to us. And I think I'm at my 5 minutes or a little bit over. So thanks, everyone.
Please remember to identify yourself if you have a chance.
This is Andrea Thomer, University of Arizona. Are there people costs associated with the on-prem servers versus the cloud storage? So are there staff that you're paying for that you can account for? Or let me rephrase. Are people costs calculated into the cost per month for your servers?
Yeah, that's a really good question, and one that we often get. We don't include the people cost in that particular cost breakdown, but the reality is that even if we were to be operating on a with a cloud service provider, we would still need someone to do the orchestration with all of the the cloud services stuff. So they're either going to be running and orchestrating the connections that we need to the cloud service provider, or they're going to be orchestrating software upgrades on our cluster. So it's our view that the cost there in terms of personnel is going to be roughly the same.
Yeah, we have one system administrator who manages about 20 physical machines and 4 or 5 racks. And he spends, a pretty good chunk of his time doing that. But he also manages, we have a Google Cloud Compute presence as well, and he manages that. And we find that he spends just as much time configuring the crazy cloud services as he does, plugging cables in to hard drives. Like, it's really, we're at a scale that one person can kind of handle most of the systems work, and it's not that big of a deal. So we kind of consider it a wash, like with which one requires more sysadmin time. Like,
This is also a niche question. I'm sorry. Niche and probably naive. Where are you physically keeping these? Like, did you have to argue for space to keep the servers, or was this easy for you to figure out?
Jeanette?
Yeah, that is one of the benefits, of our association with UCSB is that we have dedicated space in the North Hall, UCSB North Hall Compute Center. And so we also have replica servers at our office in NCs. So we have a couple locations where we keep hardware. But the short answer is, I think we ask for space and we pay for it via indirect costs of from our grants.
I'll be quick. Everyone, I'm Vishu Nandigam from the Supercomputer Center, and today I'll be talking about Open Topography's case study. So Open Topography is an NSF-funded facility. We're kind of small, a collaboration between Earthscope Consortium, ASU, and the Supercomputer Center. So we provide open access, web-based open access to topography data, so open topography, along with on-demand processing and visualization tools, and along with a lot of education and training materials on how to use these data and make the maximum benefits out of those. So what kind of data are available? I think we have a range of data sets from high-resolution topographic data, primarily derived from LiDAR, meter to sub-meter resolution. We also have regional and global data sets. We have the whole of Switzerland at 50 centimeter resolution to popular data sets like SRTM. And we don't host all of these data sets. We split them between, some of them are hosted by Open Topography. All of NSF funded data sets airborne LiDAR data sets are hosted by us. We have agreements with state of Indiana. We have agreements with Land Information New Zealand to distribute their point cloud data sets. We also run a community data space for the long tail of researchers who are in smaller institutions. They collect an area study, they submit it to us. We enforce ISO 19113 standard, so they get the whole fair data treatment, DOIs, and everything else. And then we provide federated access to big collections like USGS 3DEP, the NOAA Coastal, Polar Geospatial Centers, Arctic DM, REMA, among other things. So this is the storage aspect of Open Topography. On the compute side, we also provide value-added services on top of these data. So it's more of an equitable access. If you do not have resources at your institution, you can still come to our portal, run all these jobs running on clusters, on supercomputers to generate change detection, visualization, canopy heights, hydrology analysis, and everything else. And on top of that, we also provide multimodal access pathways. So it serves a range of user expertise. So if you're a new user, you can come to our portal and everything is done for you through guided user interfaces. If you're more programmatically savvy, you have REST API access, we have a stack catalog, we have cloud native access, so you can do all sorts of reproducible workflows. So who are the people using it? We have almost 500,000 registered users. About 39% of them are from academia. And in an ideal scenario, we'd put all our systems on the Amazon AWS or Google, wherever, do automated load balancing, redundancies, everything. But unfortunately, if you look at our usage, just the data destination part in the last 12 months, this whole cost comes down to their entire infrastructure budget. So we can't afford to go completely to the cloud. And this is only growing as more software tools start integrating us into their packages, as more students start using Jupyter notebooks and everything else. So it's kind of hard to do this. And while we serve, I just want to note that while we have federated access to some of these collections from USGS and NOAA, these are restricted to academics as of now because we do not have enough resources to serve and the whole community, make it open. So how do we handle this? So we have a fit for purpose cyber infrastructure model. We do have a little bit of on-prem compute and storage. We do a lot of analytics on who's using it, how they're using it. So all the high demand data sets, we put it locally on our systems. We're based out of the Supercomputer Center, so we have a very high-tech machine room. All the portal, all the high availability things are on-prem. And then we also use AWS, where we're federating all these data sets that are sitting on AWS resources. So we want the compute to be compute proximity to the data. So we have some operations over there. We also leverage a lot of national resources, so shared HPC allocations. Some of our some of our algorithms are very compute intensive, so we leverage the supercomputer resources. For example, the hydrology on SDSC's expands. Sometimes we need to test out some security vulnerabilities and all those things on our systems. We use jet streams for that. And again, we do a lot of analytics on who's using our data. Some of our federated data sets, if we realize there might be on risk, we kind of replicate them on the open storage network through an allocation. And then finally, we leverage a lot of institutional resources. For example, we do a lot of our cloud native access data sets are all sitting on SDSC's managed cloud disk. They use Cumulo on the back end. And we use a lot of other, so it kind of keeps data egress at reasonable to zero cost. So in a way, we're matching our infrastructure strategy to the workload. So our main thing is to control variable costs. And by variable, I mean the data egress as a data facility. That's our biggest challenge. Also, the data storage costs. We do borrow a lot of scale. It's nice to leverage all those investments NSF has made in access. So we do a lot of that. We also leverage institutional agreements. We have AWS resources, but we get it quite subsidized. CloudBank is based at the Supercomputer Center at UCSD. So we somehow piggyback on that and get reduced negotiated rates on those things. We also leverage a lot of institutional resources, like the DOIs that we provide are by California Digital Libraries. We get security scans, everything going. And beyond shared compute and resources, we keep the facility evolving. We're always learning about new technology, new standards, new things coming up. So that helps us with sizes, data formats, and everything else. We also do a lot of usability improvements via community engagement and looking at our logs at what people are doing. So sometimes they might not need all the data that we're serving. So while talking to them, we realize that we get rid of that and we cut down on egress. And then there's the sharing aspect. I think a community like ESIP is very helpful, where we learn what other people are doing. And sometimes it's just a matter of being aware of what's out there. So a lot of it is knowledge sharing, which helps us quite a bit. So thanks. Any questions?
You said something about CloudBank and you got reduced costs. So we also using CloudBank, but we're paying the same amount like anybody else.
Well, I meant relative. I meant relative to going to AWS directly as a institution. Like if I went to AWS directly, even if I did the 1 year upfront, it would still cost more than if I went through an institution. This thing like CloudBank. I think they use a third-party bulk seller that contracts them. So we're kind of getting a subsidized. We're getting somebody in the intermediate who's buying it in bulk, and then it's called Strategic Blue. So they sell it to us at a lower cost. So it's kind of cuts it about 1/3 or something.
Is it available to other people too on CloudBank?
Through CloudBank, yes.
Because I asked and I said no.
So let me clarify. CloudBank is available to any.
We have okay, let's discuss it in detail more. Yeah, it's probably too detailed now, but
Sure,
yeah. Okay.
I'll be happy to talk.
I'm Jennifer Shupp. I'm at UT Austin and the Texas Advanced Computing Center. I'm actually not on this part of campus. We're based about 20 minutes north of here. Sure, Matt, leave me this. Oh, there we go. So my talk's going to be a little bit different because we're not a geoscience specific resource. We support science across the spectrum. We're part of UT Austin. We're part of UT System. We're funded by NSF, NIH, DOD, DOE, you name it, including foundation funding, and we support research computing writ large. We've got about 200 staff members, and pretty much one of every type of resource you can imagine. We're used by a lot of different projects in a lot of different places. I think a couple of you saw the talk I gave yesterday on the 14 petabytes of data we moved from NCAR up to TAC as a emergency rescue kind of thing. But we work across science and across researchers. We currently have job submissions about every 7.5 seconds, which is somewhat terrifying. We support users not just to work with HPC. We have specific staff that will help you with your workflow. So if you're moving from one system to our systems, we have people who can help you with that. We have people who can help you support your data needs. We have both disk and archival data needs. We have people who, if you're moving data completely independent of UT Austin and TAC, you're moving from Santa Barbara over to Renzi, we can help you speed up that data transfer. This is from my team, this is their candy. They love working with large data sets and data movement, and it doesn't have to have anything to do with us. This is what we're funded for as part through the Leadership Class Computing Facility Award that we have from NSF. This is a major facilities construction award. It's moving into operations. I think the proposals due this week. We're actually even in the horrendous presidential budgets. So what this is a somewhat of a centralization of high performance computing resources supported by NSF, because as machines have grown and resource needs have grown, they've become harder and harder to run yourself. So someone 2 talks ago mentioned how, oh, we have a little bit of space over here. We have 2 floors of this data center. Each of the racks I'm going to show you have over 200 megawatts of power needs. That's for the GPU racks. The storage racks, I'm told, are somewhat worse. We're currently in the process of deploying Horizon, which is the first machine as part of the Leadership Class Computing Facility. It's got 28 GPU racks, each with 144 GPUs. They come out at 215 kilowatts per rack, so very large. They started doing tours. This is actually another 15 minutes north of where our main campus is. They're going to be open to public use. This is approximately July. It's actually starting on Monday. We've done the initial allocation. Staff have been using them for the last month. We'll have CPU racks coming in shortly after that. The storage racks are also up there and running. This is what the facility looks like. This is the under the floor part, because they're both water cooled and mineral oil cooled. They're huge. These racks, that's one in a box. That's the hole in the wall we had to do because each of them weighs 6,000 pounds. That's 2 Honda Civics. So we can't use the ramp. We had to adjust the doors and the designs. This is a standard ladder. They're 9.5 feet tall. The doors by themselves weigh 800 pounds. You can't open them open an empty floor tile because they tip over. We now have snarky signs reminding people that gravity exists, so don't do this, please. We had originally designed this to have 400 petabytes of all solid state storage. This little thing is called a ruler drive. 30 terabytes of data, $20,000 each. And that's the price from about a year ago, which we got locked in. We're extremely lucky because right now this is almost 5 times as expensive. We went solid state in part for reliability and access rates. We may have to put in a spinning disk as a middle ground just because the solid state prices have gone up so much over the last 18 months. But right now we're a VAST-based solid state. We've also upgraded the tape system. It's now up to over an exabyte of tape. And for those of you familiar with long-term data storage, your tapes need to get upgraded every 7 years, whether you want to do it or not, because they decay. We also are the team that did the 6 pallets of 8-track tape from Arecibo. and dealing with how to handle that data and recover that data, which was the only copy of some of their data sets. This was built around science from the beginning. We had these characteristic science applications, which the acceptance for the machine is based on how fast can we get these applications, not made up benchmarks. We're built around real support for real science. So I'm the LCCF science liaison. I'm going around and talking to a lot of different science groups. We have a simplified allocation process for large science users. Make your argument to me that you're a large science user. It's left a little bit fuzzy. 0.5 petabyte of tape, 20 terabytes active storage, 5,000 SUs on Horizon, which is more than most of you are going to use in 10 years, or the appropriate resource. We'll have that conversation. Couple VMs if you want front ends to your active storage. We also have support to move to TAC. There was a question about costs and costs versus cloud. We've done work with other large-scale science projects, including VLBI, and I'm not making this up, a Russian technocrat looking for alien life. We're somewhere between 6 and 12 times cheaper than you have to pay for cloud storage and cloud compute, and we don't charge exit fees. We've run all those numbers. 6 to 12 is about a year ago, 8 months ago. It's probably even better than that now, based on how cloud prices have shifted. And that includes full staffing. So we have 24/7 support. We have people who they specialize just in how to move data in and out of the tape storage. We have people who tune the solid state for applications as needed. We have people who have worked in every language you can imagine to speed up workflows. And that's part of what TAC offers to science communities. We also have end-to-end data movement services. I mentioned that. My guys love to do this. Give them the weird problem and we'll figure out where your data is going. Some of you know me as an international networking person. I wasn't a networking guy when I started. I wound up being one at NSF because I knew how to spell networking. And I'm amazed that networks even work or that your cell phone works the more you learn about it. They're really complicated and they have massive failover. So something can go bad and you don't know that it's bad because it's still kind of working. Anyone can ask for this support. This is my email. As I said, this is a little bit different than some of the other talks because we're not geoscience specific, but we are working across large-scale science projects. Thank you. I don't know. Steve's got a question. That's
Steve Diggs, Scripps Oceanography. Jen, your thing brings up with the solid state storage devices and the cost. Why NSF is willing to go for that over, funding various repositories. Why are they making the choice to invest heavily in TAC as opposed to other things? What's the feeling?
So it sounds like you're asking why are they investing in a centralized facility as opposed to individual archives across the different directorates?
Yeah, and I think given the fact that we know that domain repositories add great value to the data and they are essential to the quality and the sort of interpersonal services that they render to the community.
And I would agree that the archives and the domain experts running the archives are essential to this. All we're providing are the backend services. So we're working with the domain experts and saying, here is an option for where your archive could sit so that you don't have to run this out of your closet, so that you don't have to worry about security patches, so that you don't have to worry about, hey, my server is like 17 years old. Or, we've worked with people where their servers are old enough to vote or buy alcohol. Those servers are not going to last very long. You can either plan your outages or your outages will plan themselves. So what we're offering are services to the different science domains. So the analogy we used to use for LCCF prior to last fall was, the same as NCAR is the hub for climate science across the US and internationally, TAC was going to be the hub for high performance computing and storage resources. Not a great analogy in the current environment, but it's still a way that NSF can support science across all of the different domains without each individual directorate supporting it. geoscience was a little bit unusual. When I was a program officer, I was a rotator in OCI, then EPSCoR, then Geo. Geo actually supported domain-specific archives. Many of the other divisions did not. Biology didn't, physics didn't. So I think it's trying to find support from other places. Is it the right model? 6 to 1, half a dozen of another. There's a lot of ways this could go.
All right, so we're on the last question of the Slido poll for anybody who's filling it out. Then I'll try to review what that would be. So I think we can open up the floor to discussion. What we had hoped to do in the remaining half an hour is to kind of talk through the issues that are both preventing and opportunities for shared infrastructure. So is your repository or data facility amenable to shared infrastructure? You heard a few examples here, I think, of both sides of that. What shared infrastructure would you use or adopt? Like if you had something available to you today? I know when Jen mentioned that these storage systems were available on a Council of Data Facilities call a few weeks ago, I think there was a tremendous amount of excitement among people in the room, like, what? That's available? And everybody's like, oh, that's something we'll use. And then what infrastructure might you be able to provide? And what's your vision for how we can help each other? I think the barriers that were in those Slido poll slides are telling, right? So the issues, there are challenges to actually doing this in a realistic way. And so like, it's one thing to say we should do it and conceptualize it. It's another to like figure out an operational way to make it happen from the ground up. So I asked the question of, are you directly involved in operating a data facility? And that was 68% yes. So I assume that we're pretty complete there. I said, for the data facilities that you operate, what metadata submission platform do you use? So CCAN, Metacat UI, Dataverse, GeoNetwork, MD Editor, in-house custom, or other. So we had, it's like a couple on Metacat UI was probably me and Jeanette. In-house custom was 60% and other was 20%. So that's, I think we're all using different systems, which is not surprising. What's your on-prem versus in the cloud status? Looks like we've got about evenly split between on-prem, commercial cloud, and kind of hybrid both for people, which is also interesting. For the data facilities you operate, what do you use for an authentication system? Couple Keycloak, couple Global Auth. OAuth is prevalent. In-house custom, there's still a few. I don't know if this is something that we could all share or not, but I always find it fascinating that we all have to have people log in with ORCIDs, and yet we've all written our own stacks to do so, or we're adopting stacks that other people have written to do so. All right, this last one, I got to figure out a way to show this. I need the, yeah, I need the that would work too. I need the admin password over there too. Yeah, I don't have Zoom over here, so.
What is it?
It's just a word cloud that everybody filled out. I wanted to show. So, low tech, nice.
Hold the microphone up next to the computer.
I'm a Luddite. Let me tell you.
All right, so here's the, whoops, it's moving around though. I can't quite see it. So, yeah, this is the what are. Yeah, give it a second. I'll get the video up. So, can't really see that well, can you? I think many of you can see it.
We cannot come to the front.
Yeah. So we've got legacy infrastructure, technical debt, time to refactor, social obstacles, historically grown systems, metadata cost, CDF. So just a barrier, I guess. Read write auth API, 2018 to 2020. Is that a COVID reference? I don't know what that is.
That was, I had a longer sentence.
Okay.
2018 to 2020 was the time that we had the shared infrastructure.
Right. Yeah.
So that's what it refers to.
Yeah. So cost sort of came up as a big one. And then what's one service that you need and wish that somebody else would provide for your facility? There's a bunch of things listed here. They're all roughly even, at least looks like. So a CDN, replication, data curation, visualization, large-scale storage and access, succession planning, long-term archiving and access of data holdings. Wait, I thought that was our job. Okay. Open S3, failover storage, all good stuff. All right, so with that, I'm going to come back to these discussion points and open the floor. And I invite everybody that spoke and everybody online in the room, if you have questions or comments, please feel free to speak up. Yeah, I'm looking right now. I saw a nice talk from Dave Blodgett. So thank you, Dave. And I'll try to keep an eye on the Slido Q&A too. So I know, Kirsten, I interrupted you earlier. You had a question for somebody, so I'll give you that opportunity.
It was actually broader, maybe broader. Thank you. What I wanted to post out there is how, considering the shared infrastructure of software, of repositories support, those who are like Nick was talking about Fiesta, you were talking about Metcat. How customizable are these? We did not move to any one of those because we had established curation workflows and specific needs, such as, the linking with sample identifiers and so on, that kept us from moving out of what we had. How easy is it to, make changes to the metadata schemas, to the workflows, to administrative support, like curation workflows, in order to serve a broader community?
Yeah. Are you going to answer Kristen's question?
No, I'm not gonna answer.
Okay. Anybody want to answer her question?
Yeah, everything you guys are writing is, very flexible, anything other than not you, if you have, no, I don't have. I have another question. But,
I think.
Can you hear me, Matt?
Yeah, go ahead.
I guess my comment on that would be, and Kirsten, we've been around for this thing for quite a while. Maybe it's less of a dozen people trying to figure out something than groups sort of comparing to each other and seeing how their infrastructure matches. And I'd be happy to try to do that with people and see if we can move to their place or somewhere in the middle, or they can come to us. Maybe that's a way forward, as opposed to some one big thing for lots of people and then build on that. I don't know.
Just a quick comment to follow up on that. We have internally just gone through a process of migrating a system, and that's not trivial and costs a lot of work. And I think that's the other important aspect, is to move into something different, to do a transfer. Where do the resources come from to join forces, right? That is clearly something that needs to be also addressed.
So while I totally, I understand your concern, and I think it is one of the major issues, is that there are compromises using somebody else's platform. It's, even if it's an open source ecosystem, you might have to do a lot of work to customize it if it's not doing exactly what you want. But I can say there are platforms, like I think CCAN is a really great example of a universe of data repositories. I don't know the numbers, but I would guess there are thousands of them that are all sharing a platform and successfully building out data repositories much more cheaply than they could do by writing their own software. So it's just a matter of there are probably features any of these platforms don't have that we need. But should we pull together in the same boat with the same oars, or should we all be on our own boats? Like,
Yeah.
Yeah.
I'm going to second that. One of the other hats that I wear is I'm the PI for the University of Texas System Open Source Program Office. And we support open source software writ large for researchers. And building the community around single tools and not letting the perfect be the enemy of the good is really important in this space. I work also a lot with different researchers, especially in bioinformatics in Africa. And they have the saying that if you want to go fast, go alone. If you want to go far, go together. So maybe all of the customizations and specializations aren't 100% required. Maybe you can make adaptations to your workflow. We've seen that a lot in open source.
Are we done with that question?
yeah, please go ahead, Ted.
Okay, so yeah, what's interesting to me, I'm Ted Haberman. What's interesting to me is that everybody in this room that gave a talk and the rest of the people in the room as well are all using shared infrastructure already, which is called DataSite. And you all are already paying for it. And only one of you is using it effectively. Okay, and because I've looked at most of the metadata for most of the groups in this room, and I know who it is, but I'm not gonna. No, I'll tell you tomorrow. Oops, two. I'm sorry. There's some others in the back that I didn't see. But so in terms of there's using shared infrastructure and there's using it well, and anybody in the group that's working with DataSite. And that's everybody that's interested in improving how they're working with DataSite. I would be happy to talk to you and happy to help move in that direction. And yeah, I think, and it's really about sharing. So it's all about, I mean, sharing is the main goal. And we can really do a lot of things with DataSite that we're not doing, things that go far beyond getting a DOI, which is sort of what most, 11 years ago or 2011, 14 years ago when DataSite started, that's what it did. But it's actually expanded capabilities much more since then. So, I mean, and that's, I don't have to convince you to use that shared infrastructure because you're all using it and you're using it as a representative for a lot of others. And there's a few people here where CDL is representing them in the relationship with DataSite, either by itself or through EasyID. But so anyway, there's a lot of work that we could do just to use that shared infrastructure, I think, more effectively. And I'd be happy to help.
So just a heads up, I think Ted was talking about us not using that one effectively, and which is true because we don't really care about anything else apart from a DOI. So a few years back, before schema.org came up as a EarthCube project, we worked with Google to see what the best effective way was before it became schema.org. And I think our main goal here is we keep the metadata with us, the entire ISO 19113 format spec. So it's all the elements that are there, but we use it effectively as an interface to different standards. So that's why we have Stack, we have CSW that gets federated by data.gov. We also have a schema.org spec, but everything is dynamic coming from a centralized listing. We could easily turn on another for the CD, and you're right, we do use DataSite via digital libraries, California Digital Libraries and EasyID. We could easily turn around. We didn't see the purpose in that, but it would be nice to understand what the purpose is, like who's consuming that data, because we analyze traffic trends of how people are finding us or regularly do, like how people are accessing. So it'll be interesting to know that also. So thanks.
Yeah, thanks, Vishu.
I mean, I agree, but we don't know who's using it. But you're still paying for it. Well, CPL is paying for it. As long as my project is still paying for it, I'm good. Pretty broad. Institution.
So,
Right now, in data science, there's 140 million things.
That.
Yeah. Yeah. So there's 140 million things right now in DataCite from almost over 4,000 different repositories, and there are a lot of people that are using it, and that population that's using it is changing and growing. And I think this is a good time to think about joining that. As long, I mean, Google Datasets, that was the really cool thing. It was so cool, in fact, that ESIP formed a cluster called SOSA to work on schema.org. And then it turned out that Google wasn't really all that interested in data sets. But it's, in this case, I think the bandwagon is certainly as strong as the Google data sets bandwagon was when we were doing that. We're very happy. Yeah.
So, I mean, Sosha has pivoted to trying to work with DataCite to get compatibility. I'm sure you're aware, I guess.
Yeah.
so there are a couple questions in the Slido. One is about basically that it seems we have the following data repository types: on-prem, cloud-based, and hybrid. Can we support all of these types of repositories with shared resources? Can we make them interoperable? Yeah, good question. Jen asks, why do they need to be interoperable? If you're online and you ask this question, feel free to unmute yourself. I believe that's possible, right? Yep.
Well, and I'd also argue, the cloud is just somebody else's computer. So TAC looks like the cloud to a lot of people. It looks like on-prem to other people. So
Yeah.
I guess I don't even know why that matters for a lot of these data repository types. I think the data repository type, what matters more is how you're going to use it. If you're going to use it as an input to a computational model, you want it near the computation you're going to use. It doesn't matter if it's on-prem or cloud or hybrid or something. It just, that proximity is what's important. If you're going to use it to just download to your laptop and do your own visualization, you want it somewhere that's not too far away, and you want a big pipe, and you want to make sure your laptop is not on the wireless.
Yep.
So I guess I'd be interested in whoever asked the question to give more details so that we could try to answer it a bit better.
I mean, I think one of the things Jeanette's talk sort of talked about our use of Kubernetes and container-based deployment. I think one of our goals with that is to be able to move our whole infrastructure around from different data centers to other data centers so that we can use our on-prem Kubernetes cluster and then move it to someplace else if we need to. We sometimes use GCP. We sometimes use other stuff. So it feels like the more we have that ability to make choices that drive our stuff around different infrastructure, the more flexibility we'll have to do other things. So there are now a lot of hands in the room. I'm going to go back here first and then.
There's one more.
Yeah.
Are you guys or y'all running your own Kubernetes clusters locally too on-prem?
Yeah, we're running a Kubernetes on-prem with about 768 core, multi-node machine. It's a mesoscale cluster. It allows us to do a lot of our local data processing without necessarily, going off-site.
Yeah, I guess I'm wondering what your staffing footprint looks like for doing that.
We have across, like I said, we're running those 15 repositories. And so we have one sysadmin that kind of focuses on hardware and deployment. And then we have more or less 10 DevOps engineers that both do software development and operational work. And they're spread across a lot of different platforms and projects, not just running repositories, but doing machine learning work and helping, facilitate analytical workflows and all sorts of stuff. So it's quite a crazy, soft money driven kind of endeavor. So it's probably hard to really pin down what exactly our staffing costs are for running the cluster, but
I was just thinking number of people because that's been a blocker for us running it. So I just get curious. Also, is it the case, I'm sorry I missed your talk, but is it the case, since I see the NSF logo up there, maybe you can answer this too, like at the NSF computing facilities, so sorry, I'm from the Department of Energy National Laboratories, different vibes within our computing infrastructure. There's no real good, solid, robust support for Kubernetes across our whole infrastructure at the moment. And so we haven't made that investment because we don't have the staffing available to do it. So I was just kind of curious, is it available uniformly across all NSF compute facilities? Like, and how do you think about that? Or are you just thinking, hey, I've got on-prem and I'm going to use the cloud, and I'm not really worried about multiple NSF centers?
So
sorry for the rabbit hole, but
no worries. We were talking about a UCSB data center, not an NSF one, but we do support some NSF data facilities. There are some DOE facilities as well. So the at NERSC, they have their spin facility. Yeah. So ESS Dive, which is one of our sort of companion repositories, uses their Kubernetes infrastructure at spin.
So if you go to the access-CI website, it lists most of the bigger NSF sites, and some of those support Kubernetes. I'll also tell you that TAC supports Kubernetes use writ large. So I think there's a variance, because if you tune resources to use Kubernetes, you're not going to be running AI models there. You're not going to be doing some of the really math intensive data modeling. So we're at an advantage that we have a lot of different things, and so we can match you up to the best thing. And one of the challenges we've actually had, I've had over the last couple of years of talking to science teams is like, oh, I have to have GPUs and I have to have a lot of them. And when we look at codes and do diagnosis of codes, yeah, not so much. Out of the box, we say about a third of our codes can GPU great. About a third of them can use GPUs effectively with some work, and about a third are just never going to get there. And that's okay. But, I think part of what you're dealing with is at the Department of Energy, they've really gone AI GPU centric. Yeah. And that's not a bad thing. It's just a different science mix.
Yeah.
So the same as, the question of what kind of archive should I have? Well, it depends on how you're going to use it. So anyway, sorry.
Zhang?
Someone back here?
So, and I'll make a note that we're about 6 or 7 minutes out from the end of our session. So
Hello, my name is Zhong Liu from NASA Disk. So basically, right now we're migrating our data from on-prem to NASA Earth Data Cloud. So basically, our service we have to redevelop. We cannot just simply move everything down to the cloud. So that's the some kind of challenge here. Yeah, and there's because it's a time consuming to redevelop those services. So there probably are some kind of gap, there. So, yeah. I think, well, I don't know. I think, for probably depend on that scalability. If I have one or two video files share with my friend, I don't need to go to the cloud, right? I can email or dump somewhere, But if the world, see my video, I post it in YouTube or something like that, Yeah, probably depend on your purposes.
Yeah, I think that is one of the challenges we've had with this whole discussion, is that we have repositories that range in size from the very small to some of the largest environmental science repositories in the world. And just like listening to your talk, Doug, about transferring your data archive over to TAC, it's like different set of questions than we might have, with Neotoma or, some other kind of data system. So it's not a one size fits all. But I still feel like there's opportunities for us to talk more about how we do things. Doug, did you have a question?
Yeah, just in general, NSF's made lots of investments in facilities and computers and storage and all that. So, through CI Compass, community practice, can we explore options for using things that are already built and paid for that we aren't doing, and we're building bespoke things? Like, I think we don't even know a lot of these things exist. That's a challenge within our organization across NSF. So how can we better use that? And then I have got a data center that's not for sale. But we have a success story where we just deployed the USGS supercomputer along with their storage environment in that data center as a co-location facility. So that's a great example of efficiency.
Yep.
So I think we can do that with others, and part of that agreement is to build kind of a data commons across NCAR and USGS. So how can we better share our data? So if, that's an option we can look at, we'll be fine. We can, look at, if you want to co-locate something there, we can do that. If you want to augment our Kubernetes infrastructure, you can do that and carve out a space for you to run on that, that type of thing. And, attack and explore similar opportunities, and why not reuse the things that we have?
Yep. Martin up here had a comment.
That was really the gist of what I was trying to really figure out. How can we leverage stuff that already exists, so we don't have to pay for things that already is there. We just don't know that it exists, or the pathways for smaller groups to get there is obscure. We don't really know. Essentially, bringing much more transparency of what's available, how to get there, and then lots of things will be much easier for smaller repositories like BR.
So I'm going to agree that we should be taking advantage of the services that are offered, but that means changing a mindset. There's a whole lot of non-invented here syndrome, right? When I was at the NSF, my appointment was through the Woods Oceanographic, and I worked with a ton of data scientists. And if they didn't get their hands wet gathering the data, they didn't trust the data, right? We're in the same place now with software. We see this with open source software all the time. How can I know that that's going to do what I want to do? It's going to do it not quite right. So you have to do a trade-off of services and costs versus control.
Yeah.
And that is a hard trade-off for many researchers.
And
it's just something to recognize. I'm not saying where on the spectrum we should be.
And I think we're in this room right now because in the past, when we were more flush as a community, those questions felt more distant, and they feel a lot less distant right now than they have in the past. So it feels like everybody's evaluating like how to be. Yeah.
So I'm an outsider on this. I don't operate a repository anymore. But it seems like you all have been diagnosing this problem for a long time. Why don't just 2 or 3 data centers get together and do something? I mean, I mean, you did, yeah. So I think that's a big data center.
You can do more.
And do more, right? I mean, so it's just,
Yep.
I think you just have to learn by doing. And so just Jen's offering a bunch of resources. Just it's new. You got to do something new, and you have sunk costs, and this will require an initial investment that will save over time. But as Matt said, it's getting real. So, I mean, you just have, okay, I'm sorry. I'm an outsider. It's easy for me to say, just pair up and do it.
Yeah. This is easier. Pairing up and doing it. I have found in my limited experience, you can't cross agencies easily because Congress cares about where their money goes. And then within the agencies, within the compute facilities, you've got people that have like very strong feelings about how their facility is run and keeping that money flowing to their facility. So they'll stand up and say, we need things to be interoperable. We need to connect. But what they hear, what they mean is you need to send me all of your money and I will just run stuff for you. And so like this social problem exists within the data too. Everyone wants to hoard onto their data, but they all want access to everyone else's. We have a social problem. The incentives are fucked. And like, so to your point, like you can get a coalition of the willing, but it only goes so far unless you've got the whole director of a facility bought in and making that happen. And frankly, I don't see that. I was really curious about this discussion for this purpose because for, I don't know, probably 10 years, we've been talking about integrated research infrastructure within DOE. We have not been able to get federated identity working. And that is a blocker. If you can't do identity, then you can't do authorization. And then you've got users with a real, no, I'm not saying that, but I'm saying like we need to own the fact that like
It's also a human issue in part.
in part, but it's a management leadership like.
But on the NSF side, all of the access resources are using the same federated.
And the cloud has figured it out. And I'm just saying it's a human and leadership issue that you can't solve with technology.
I agree with that. Yeah.
Okay. So we're at time. Yeah, exactly. So I'm going to thank you. That was wonderful spirited discussion at the end. I love the energy. Fantastic energy. I'm going to wrap with a plug.
So you come out with an agreement.
So
6 years ago or 8 years ago.
okay, we did try. And that's the nature of our soft money world. But that said, we still have opportunities to meet and discuss. And one of the things that ESIP does really well is bring us together. So the Council of Data Facilities meets monthly, and Nick has been really great about reconvening those. I think the group that has been, a small group has been meeting kind of regularly, and I would like to see a larger group come and participate on a regular basis and try to actually hash out some of these issues and find those small steps that we might be able to take the pairwise things and actually make some forward progress on some of these. We learned about Jen's offer of storage a few weeks ago on that, and it was super exciting for everybody. That was a lack of knowledge thing that now everybody knows. Maybe not everybody. I'll bet if we ask all those 68 repositories in Data One, they are unaware of it. So we need to spread the word a little bit better. But please come to the monthly CDF meetings, and we'll try to continue this discussion and see where we can bring it.
If you want to get an invitation, just put your email in the notes, and then we can invite you, and then at least we keep more people involved in it. But definitely, we have shrunk a little bit, so we need to bigger, but the problem has not gone away. So let's maybe get more people involved.
Thank you. Thank you to all the speakers.
Thanks, Matt.